I want to spend a minute talking about the Prion hypothesis. Jay did an excellent job, but if you have a taste for weirdness in biology, this is a very interesting concept to wrap your head around. Instead of using animations, I'm just going to use cartoons. There's a normal cellular protein, which all animals have, or at least all vertebrates have. It's most abundantly expressed in the brain, but it's virtually everywhere. It's ubiquitous. All cells and tissues in the body express this protein. The normal protein is a well-behaved cell surface membrane protein. It's rich in alpha helical content, hopefully conveyed by the bed spring. It's highly soluble in water and other solvents. It's easily digestible by the enzymes that break up proteins, called proteases. It's a good guy. This amino acid chain, as Jay was showing you, all proteins are made up of a chain of amino acids folded in a particular way. This chain can be refolded or misfolded into an abnormal form. And when the prion protein is misfolded in disease, it acquires a number of distinct characteristics from the normal protein. It becomes rich in beta sheet content, hopefully conveyed by the saw teeth. It tends to stick to itself. It aggregates. It becomes resistant to the proteases, to the enzymes that break down proteins, so it tends to accumulate. But it's the acquisition of another property that really makes it epic setting in biology, and that's the ability, as Jay was saying, to recruit more copies of itself from the normal form. So when the good guy comes in contact with the bad guy, it's two bad guys that leave the scene. And you can conceive that this is an exponential process, somewhat like the mousetraps, where first there are two, then there are four, then there are 8, and on until all the prion protein in a brain or even in a body are converted to the abnormal infectious form.